That's not too bad. Okay, a couple more minutes just in case anybody's running late. Okay, go ahead and get set up, get logged into Blackboard, get logged into the REPL website if you need to. We'll wait one more minute just in case anybody's a little bit behind. Okay, is everybody set up, ready to go? Okay. Couple of things. So if anybody wants, I know some people like to specifically have a book. So there's a few different books. They're not crazy expensive. The one thing I have noticed with a lot of books is that they assume that you're already like a proficient programmer. It's more geared toward somebody who is a good programmer, like I shouldn't say good, like an experienced programmer, and then they're just trying to learn another language. So they tend to be very technical, and they tend to be more for like somebody working in the field. That being said, some of the beginner books you might be able to get some stuff out of. So you can read the reviews. I don't have any specific personal recommendations on any of these. The only thing I would obviously say is, remember we talked about Python 2 versus Python 3? Go in the comments, whatever book you might get. And again, book's optional. You don't have to. There's plenty of free information out there on the web, but I get it. Some people like a physical book. Whatever book you get, absolutely make sure that it's geared toward Python 3. So like this book right here, I'm guessing it's from 2015. I highly doubt it's based on Python 3, yet it's still on the top. And it looks like they have like an updated edition from 2019. This one's probably more geared toward Python 3, I'd imagine. But either way. Okay. And then there's just a million sites out there. The official documentation is not super user friendly, I think, for most people. Like chapter 1 stuff they're talking about the interpreter and source code encoding. I think for most people, like this is like supposed to be tutorial level stuff, and you're talking about character encoding. It's just, that's how a lot of these tutorials are, unfortunately. And the other thing is that some of them go out of order from what I would consider the best way to learn a language. For example, they'll talk about, before they even talk about if statements, they're talking about some of these complex topics like lists and tuples and sets and dictionaries, and then they're talking about if statements. To me, that seems a lot out of order. So for the most part, you should be okay with just the stuff I give you in this course. But again, there's plenty of resources out there. So there's that. The other thing is, at some point, so anybody who's taken a class with me before, like a programming class, especially a 2.5-hour class, you'll know that I usually lecture for like 2/3 of the class, and then the last little bit we'll do some like in-class assignment or something like that. This split schedule makes that kind of hard. So what I'm going to do is, for the first few weeks, we're going to have normal lecture, but then every once in a while, and I'll let you know the dates ahead of time, I'm going to say, hey, this class we're going to reserve for anybody who just is, needs some help. It's not going to be a lecture class. It's going to be more like doing an in-class assignment. And I'll let you know that ahead of time so you're prepared, okay? Does that make sense? Because really the best way to learn how to program is just writing code. And so me sitting here lecturing all day does absolutely nothing to help you. So the more assignments I can give you to really help you along that path, the better. Okay. I got the YouTube stuff fixed, so I got that one from last class uploaded. This seems to be doing a little bit better. It's dropping less than 1%. Oh, now it has to go and start doing this. I think it'll be okay. Computer science, so we have two networks. We have the main school network, and computer science has its own network, and I've noticed the computer science network has been really slow the past few days, so I don't know if there's something going on. Anyway, but that's out there and available to watch. And I haven't posted any code examples yet. Last time the stuff we did was so trivial I didn't post it. But from now on, I'll also post all the code examples from class. Okay, so everybody good? I'm ready to go? Okay, let's open up a new REPL. What's this Python Learn website? Oh, yeah. By the way, I included this website. This one seems to be fairly complete and fairly simple. But again, like I said, some of the stuff they do is out of order. Lists don't really make sense until you have learned loops, and some of this stuff to me is a little bit out of order, so I don't care for it. But this one, it seems easy enough. One of the things it has is like an interactive thing where you can actually write code. You run it and it tells you if you ran your code correctly. Almost like little practice problems. Now, these practice problems are very, very, very short. It's not like you're writing actual programs, but it might be worthwhile just for a little bit of extra help. It's not going to be required, but I just try to give you resources where I can. Okay, so let's go ahead and get started. And again, you type what I type, and then anytime I'm like going to write some code I know that doesn't compile, I'll let you know that ahead of time. I'll say don't type this. Okay, so let's just talk about what we talked about last time. We did our hello world. So print is what's known as a function. I think most people from talking about to everyone last class, it sounded like you knew what a function was, but the basic idea is that it's a reusable piece of code. And in this case, somebody else wrote the function, but we're going to write our own functions later on. And you pass it some data, and then it does something with that data. Okay, so in this case, this function printed whatever text we give to it, it prints it to our terminal. This thing is called a string. And in Python, and actually this is not unique to Python, a lot of scripting languages allow you to use either single or double quotes. You'll probably see me bounce back and forth. I've noticed just out of laziness, a lot of times I'll just do single quotes. If we want to, what's known as concatenate things together, we use, let's do this. So we're going to use what's known as an F string. Okay, remember we talked about that? And so if I want to say 1 plus 1 is equal to some number, any code that we put inside these curly braces is going to be Python code. So we have this thing, and this only works if it's got the F in front of it. Notice here that it actually gives us the full thing. As soon as we put the F in front of it, it means, oh, there might be some Python code in here to interpret. So any code we surround by these curly braces is going to execute. Now, most of the time, we're actually not going to execute Python code like this. Most of the time, the bulk of the time, it's going to be because we want to get the output of some variable. This is kind of like a made-up case just to show you how it works. And then we also introduced this idea of a variable. And we can call it anything. So I can call it X or age or just whatever is most appropriate. Weight. okay? And whatever the first value you assign to it, that becomes the data type. So in this case, if I assign 52, so let me take a step back. So show of hands. I know I did this last time, but just to be sure, how many people took COP2030 before or some other programming class? So either everybody or almost everybody. I think everybody, actually. Okay. So in C++, if I wanted to declare a variable for this, what would I do? Well, this is an integer, so I'd probably put int in front of it. And I might do something like this. Or you can do it on a single line, but in Python, what happens is that 52 is an integer. So because it's an integer, age is now an integer. We don't actually we don't specify the type. We don't when we're declaring it. And the way we sort of can confirm this, there's another function here called type. Okay, and as you can see, type didn't output anything, so what we have to do is say, okay, I want to print the type of age, and it says that it's an integer. It's an int. Just for review, in English, how would you describe an int? Simplest way. We don't have to be super formal about it. Yeah, positive and negative whole numbers. And we can do the same thing here. Let's say, for example, we're dealing with a variable called weight. The weight is 2.4 pounds. And then what do you think line number 9 will print? Yeah. So when I teach COP2030, if anybody took that class with me, I kind of lean on double, because it makes the class a little bit simpler to teach. But we actually have this concept of how much memory does a data type actually take up. So we have like ints and longs and shorts and all these other data types. In that class, if anybody took it with me, I try to keep it simple. I just lean on double because it's a good general purpose, and it isn't going to throw any warnings for us if we try to do addition or anything like that. Float is very similar. The only difference between a float and a double is the full name for a double is actually an IEEE something double floating point number. It's basically, we have double the precision available with a double. That's why we call it a double. So you can think of a float as the same exact thing. In this class, I'm going to keep life very simple. Think of a float as just a decimal number, okay? So in your head, because this is these are kind of beginner classes, you can just say, okay, floats, doubles, they're just decimal numbers. They're not quite that. The reason I don't want to get into this conversation is because anytime there's a Wikipedia article this long about a topic, means that we're probably not going to be able to explain it very quickly in class, and it's probably just going to confuse a lot of people, okay? That being said, so for anybody who's taken that class with me, what's the one warning, what's the one caveat I always give to everybody about using floats and doubles? When is it not interchangeable with a double or with a decimal number? Sort of. Anytime you're writing software that deals with what? Money, exactly, yeah. Because you're going to end up with these weird bugs that are off by a penny, and you're like, why, and in other software, it's not that big of a deal. Like if I'm writing a video game or a physics simulation, if it's off by a number, most of the time in the game, you're not going to notice. It's going to be such a tiny little fraction of a number, you're not going to notice. When you're dealing with money, people notice pennies showing up missing. So that's the one time, yeah.
I just noticed that I stumbled onto a whole, have you ever heard of DigiKey?
DigiKey, the part site?
Yeah, the part
yeah.
site. I noticed that they actually do use a
what's possible too is because a company like that, and this is a good topic. Like every time when we deal with money, we always care down to the penny. I'm guessing on them, they probably do even fractions lower than a penny, because if you're buying 100,000 resistors, that becomes an issue because each resistor is probably less than a penny, right?
Well, it's kind of interesting because they also do, I think it's called like some sort of, they call it rate, where if you do order a certain amount, like over 100,
Yeah.
they actually give you a 10% discount, and it just keeps on discounting the more you buy.
Yeah. I would guess though, even in that case, what you can do is with a double, you can set more precision. Basically, the difference between those two is that with a float or a double, I can set, I think how to say this. So the float or a double, they're going to be base 2 representations, which computers are really fast at. If I use a true decimal type, it's going to be base 10, which computers are very slow at, but you want that for money. So you can have an arbitrary precision with a decimal data type. And a lot of times what people do too is that they'll use just an integer, and each int represents a penny. But I don't want to confuse anybody. But for this class, we're gonna keep life very simple. This type right here, int, is going to be positive and negative whole numbers, and then this same thing, except for now these are going to be decimal numbers. Okay. Just anytime if you ever go out in the real world and start writing software with money, there's probably plenty of blogs that explain the proper way to deal with money. Don't assume that this is going to work. Okay. And then lastly, I'm going to say so str, that's just short for string, a string of characters. And again, we can be interchangeable with these single and double. I'm kind of lazy about it. In this case, for whatever reason, I happen to use double, or double quotes. Now, in other languages like C and C++, there is a very strict difference. The double quotes are strictly reserved for strings, and then single quotes are strictly reserved for individual characters. Okay. But in Python, it's, a lot of scripting languages are like that. JavaScript. What else? Probably a few. Okay, everyone's good with this so far? So let's do this. This is just going to be kind of our scratch pad. Usually I like to be a little bit more organized, but just for now, since we're doing such tiny little examples, we can keep on using this. So what's the difference between number equals 5 and number equals 5 in quotes? Yeah, one's a string and one's an int. Now, don't get confused by this, because what I might do is something like this. I might say print number times 10. So without running it, what do you think would happen? Yeah, well, for an inexperienced programmer, you might think that the output would be 50, right? But what actually happens is, who said that? You said the right answer. Yeah, what it's actually going to do, it's going to print 5 over and over and over again, okay? So, versus if this is a now this will actually print 50. Yeah.
So certain signs like multiplications and different things.
In different contexts, yeah. Personally, I try to avoid doing things like multiplying a string and a number, because a lot of people, like you typically want to write your code as intuitive as possible. And even though you might have a language feature that allows you to do something, a lot of times I might have just said, okay, well, great, I can do that, but let me maybe do this as like a loop or something like that instead, or like what's known as a list comprehension. something that's a little bit more clear, because it's very easy to miss something like that, that somebody had a number as a string and you get some weird output. Okay, so any questions about this kind of initial stuff right here? Okay, so anybody's taken a class with me before, let's open up a new one of these. You'll know I like to do a lot of these conversion programs. The reason I like to do these, miles to kilometers, gallons to liters, feet to inches, these sorts of basic programs, is because most people have learned how to do these conversions in like elementary school or middle school. And so it's like you're taking a very simple problem, but we can still learn a lot of concepts. So it's like you take these simple examples and we're learning concepts. I know it can get frustrating because it's like you want to do things and write more interesting software, but as we get toward the end of the course, we'll do that. These simple examples of doing these conversions are very nice because they're very good at showing like specific concepts without worrying about what the actual problem you're solving is. Okay, so let's do one. Let's do gallons to liters. So I'm going to have a, so I want to convert gallons to liters, so let's go ahead and put a comment. We talked about comments before, right? Comment is, in Python, it's just the hash symbol. And then from here to the end of the line, it's a comment. Okay. And let's say, for example, I wanted to convert, let's say we'll start off with 1 gallon. And so liters will be equal to gallon. Actually, let's make it plural so we're consistent. So gallons plural, liters plural. So gallons times some number. You can actually just look that up on Google. It's not going to be super precise, but it's fine just for our purposes here. So this is great. We should always try to run our code as soon as possible. I've seen people write like 30 and 40 lines of code, and then like if you do that, you don't know where your mistake is. So try to write little bits of code. This compiled, it didn't output anything, so you know, we didn't test much, but we tested at least that these 2 lines of code are correct. Okay. Now if we want to print this, we could just print the answer. But what if I wanted to format this a little bit nicer? What could I use? We just showed an example. It's called a something string. F string, perfect. So let's do that. Let's use an F string. And we can say that either result is or liters are. We'll say result is for now. Result is. And then remember, anything between these curly braces is Python code. Well, this is a variable, so this is nice. We did 1 + 1 before, but in this case, it's just going to output the contents of this variable. So in this case, it's going to be 3.78. Let's just change some numbers here. Let's say we want to convert 5 gallons. Okay, pretty straightforward. So let's do this. Open up another REPL. And I just want you to go through that process in reverse. So I just want you to do your own program, liters to gallons. Just take a couple minutes. Okay, so let's go through that process. So we have liters. So we're going to say liters is, we'll stick to 1. And then we want to do some sort of conversion. So we're going to say that gallons is equal liters times, what's the number? So I don't have to look it up. Say it again. 0.26, correct? Okay, thanks. And then I want to stay consistent. What did we say before? Result is? Oh, and then we want to make it an F string. I'm going to say result is gallons. Okay, everyone good with that? Pretty straightforward. I know a lot of this is like refresher COP2030 stuff, but I want to start off everyone gentle because the syntax is a little bit, it's different enough that I don't want to cover the whole language in like a couple of days and then start doing more advanced stuff. So we'll probably spend about 2 or 3 weeks covering the language, and then we can start to go on to new things that you haven't done before, okay? But you kind of have to be stronger in the language. Oh, and then just a couple of things that we have talked about before. Don't forget, it seems probably obvious by now, but we don't have semicolons at the end of code. Now, Python is sensitive to whitespace. So like in C++, we could have written this line of code. Like we can split code up into multiple lines. But notice that just by hitting the enter key in whitespace insensitive languages, that would have not broken the code. In this case, it did break the code. So it's something you have to be very careful about that. We'll get to that later. The code that we're writing isn't going to be complex enough. But once we get into things like dictionaries, where we have these large data structures, we probably, for readability purposes, will want to split it across multiple lines, and we'll talk about how to do that and get to it. But keep this example simple. Okay, so this is going to be x3. So let's take this example. Actually, let's do this. Okay, so we'll open up a new REPL. Now, one of the first things you probably learn in a language after you do things like variables and input or variables and output is that, okay, we know what a variable is. And the whole idea of a variable is that we want to be able to change data within that variable. If we hard-coded the data in all of our programs, it'd be kind of a useless program. Imagine a web browser where good, okay. Imagine a web browser where you couldn't actually enter in a web address. Every time you went to use the browser, you'd have to recompile the entire browser. It'd be kind of a useless browser. So that's why we have variables, is because we're going to be getting data from unknown locations. In this case, we're going to talk about how to get data from a keyboard, but a lot of times we're getting data from databases, we're getting it from network streams, we're getting it from files, and so on. Okay, that's essentially why we need variables, is because we want to be able to dynamically change data. We don't want to hard code everything. It would be essentially a useless program. I shouldn't say useless. The very first original programs, they were batch style, and that's exactly how they were. There generally wasn't like a keyboard or something that you'd be working with. You would hard code all the parameters into the program and run it, and then you get an answer. But it's been a long time since we've had to deal with computers like that. Okay. So let's talk about this function called input, and it works a little bit different than like in C++. So let's just let's do this. We'll be very generic. We'll just say x equals input, enter value. Actually, let's do this instead of x. I try to avoid using x because that puts people's mind into algebra too much. So let's say value, and then let's go ahead and print out that value. So we can do that. We can enter in some numbers. Perfect, okay. So the way this works is just like with our print and type functions, we've got another function called input. And what this function does is it takes in a string to be displayed to the user. So notice that we said input, and then we had some string, and that's what's actually displayed to the user. Everyone's good with that? So that's the one of the parameters for this input function. And what it returns is whatever the user typed in at the keyboard. So this function runs, it waits for input from the user from the keyboard, and then whatever they enter in, as soon as they hit the enter key, that is stored in this variable called value. Seems simple enough, right? Well, we've run into some issues. What do you think the type is? It's a string, and it's always a string, unlike in C++, where if I type in a number, it knows that it's a number. It still thinks that's a string. Why do you think this might cause a little bit of a hiccup? It's not a huge deal, but it's a tiny roadblock. Exactly. If we try to do math, remember our example from before, what do we end up with? We end up with 55555 instead of 50. So what we have to do is we have to change that data type. Okay? And to do that, we have different functions. And it's so like, if you remember before, we had int and float. Those actually are functions as well. And so if I want to convert that value, I do float, and then the value, and that'll return, we'll call it fval for float value. And then now if I print the type, oops, sorry. Let me kind of group this code a little bit together. Maybe that's a little bit easier to read. Oops, sorry, we don't want, sorry, that was my mistake. So we don't want, here, we don't want it to be value. We want it to be fval. Now let's try this again. Okay, now it's a float. So now anytime we want to do any sort of mathematical operation, we know that we can, okay, get input from the user. We can convert it. And then at this point now we could do fval times 5 and it would actually work properly. Now the one thing you have to keep in mind is what happens if I enter in a string. This is called an exception. We're not going to deal with exceptions for a few weeks, but you have to keep that in mind. Right now they're just going to get a big nasty error message. Exceptions are complex enough that I don't want to talk to them right now. We'll have their own dedicated section of the course that we'll talk about. But just keep that in mind for now. If you see something like this, think, oh yeah, well, probably because I didn't enter in a number. Okay. So let's use that information. I'm just saving these so I can post these later online in case for some reason you lost it or didn't type it correctly or something, whatever the reason. Okay, so let's open up another REPL here. And let's combine the information we got from here and here. So we're going to cheat. Let's just go ahead and make our lives a little bit easier. Let's copy the liters to gallons. If you already closed that tab, you can type it, I guess, but just trying to save everyone a little bit of time. And now let's go ahead and make this the interactive version. So rather than hard coding the number of liters, let's use that input function that we just talked about. Enter liters. So we're almost there. I can try to run this. But don't forget, what do we have to do? Yeah, exactly. So we can't say that we're going to convert liters. We got to convert it to a float. Now, I'm not sure how much I like this solution right here, because liters is still a string. All we've done is temporarily, it didn't do it in place. So if I were to do this, what's it going to say? What's the type going to be? Yeah, it's still going to be a string. I just temporarily did that one call. So we could do something like F liters for float. But honestly, a lot of times, if you just take in a value and then immediately have to convert it, we can reuse these variable names. And so this might be a little, I hope this isn't overly confusing to anybody. I'm assuming since so many people have taken COP2030, you've seen this before. What we can do instead is we can say that liters is equal to float liters. Now this is probably a little bit different than you're used to in like C++, because if I said int I and then I tried to do float I, what would happen? You get a compilation error. But what happens is that in Python, if you assign a value of a new type, it becomes that new type. So here, liters is a string, but now because I'm reassigning it, it now becomes a float. And so we can actually get rid of this. Now we can see here that liters is properly a float. By the way, make sure you understand that when we have assignment like this, so these single equal signs, this is called assignment. The stuff on the right-hand side of the equal sign is evaluated first. So this may seem kind of weird that like we're using liters on both the left-hand side. You're like, doesn't it run into some weird collision? The way it works is that this whole thing is evaluated. It gets the float version of liters, and then it's assigned over here. Is everyone clear on that? So I'll say that one more time. Is that anytime, this is a good example. So it doesn't like do it from left to right. Normally our code runs top to bottom, left to right. But in certain cases, like when we're using equal signs, it actually evaluates everything on the right-hand side of the equal sign, gets one final thing, one final answer, whatever that thing is. In this case, it's going to be a float. And then it assigns it to gallons. And that's why we're able to do this, is because liters here is a string. And then what happens is when it goes to run this line of code, it says, okay, convert liters to a float, and then assign it over here. It's one thing that throws some people off. I've noticed, beginner programmers, but just wanted to kind of reiterate. I know a lot of people in here have, you know, at least a semester, but just to be clear, everyone's good on that? Make sure that this code works like I think it's going to. Okay. So I'll give you one to do on your own. It's pretty easy. So start a new REPL. We don't even have to look this one up on Google. Feet to inches. Okay, so what's the conversion on that one? 1 foot is how many inches? Yeah. Okay, so I'll give everyone about 5 minutes and then do the interactive version where you ask them how many feet they want to convert and then convert that into inches. So if they give you 3 feet, how many inches should that be? 36, right? Okay, let's go over the answer because I want to go over one more thing before the end of class, and then that'll be it for today. So we're going feet to inches. So we're asking them for how many feet they want to convert, and then we're going to give back to them inches. So we're going to say feet is equal to input, enter feet. Well, feet at this point is what data type? At line 4, what is feet? It's a string. So what do we want to do? We want to convert that. So we're going to say feet is equal to... Why not integer? Somebody might want to convert a 1.5 feet, right? They might want to convert 1.5, and with an integer, we can't do that. There will be examples where it makes sense Actually, we'll do one in a minute where it makes sense to have an integer. Then we're going to do the conversion. So we want to know inches. So we're going to say inches is equal to however many feet they gave us times 12. And we can just print that out. So we should always do our sanity check. We should just check. Okay, 1 foot should be 12 inches. Oops. What did I forget? F, yeah. So we want to make this an F string. Perfect. And then 2.5 feet. Perfect. Okay, everyone's good with that? So let's, have I been keeping up with these? So 1, 2, 3, 4, 5, 6. Oops, I missed one, I think. Did I forget liters to gallons? So everyone's good with this basic stuff so far. The idea of variables, getting input from the keyboard, strings, ints, which are positive and negative whole numbers, floats, which are essentially positive and negative decimal numbers, strings, which are strings of individual characters, variables, using variables with basic arithmetic like multiplication, F strings. Everyone feels comfortable with all these topics. And again, if there's anything you feel weak on, there's a million websites out there, but say for example you felt a little weak on variables, you could go through here and there's some additional reading stuff. To me, sometimes programmers make things a little bit more complicated than they need to be. I've always found for, like, when I try to recommend books to students, it's very difficult because they're always very like, they read like a math book. They don't read like a, you know, like a simple thing. So. Okay, so let's do one more thing. We're gonna change gears a little bit. We're gonna have a new topic, and then we'll call it for the day. So you've probably dealt with if statements before. And the idea of an if statement is that if some condition is true, some code is going to execute. I know that's very vague, but let's just go ahead and do that. So let's say, for example, we're writing a program that it wants to know whether somebody can vote or not. So let's say, for example, we're going to hard code an age in here. Let's say that the person is 40. We're going to say if age is greater than or equal to 18, then we're just going to print that they can vote. So type that exactly as is, and I'll explain why we have to type that like that and all the different characters and so on in a second. Still doing good? Okay. So you'll notice that if statements in a language like, actually most C-style languages, so C, C++, Java, C#, JavaScript, all those curly brace type languages, this is probably way different than you've seen before. They made this choice for, I think, readability. By getting rid of a lot of the quote-unquote special characters like curly braces and parentheses, it's not like they're gone, it's just, in the case of curly braces, they are gone. We can wrap these around in parentheses, but the goal in Python is for readability. It's the idea that a junior level programmer can read an advanced level programmer's code. At the opposite end of the spectrum, has anybody heard anything about a language called Perl? What's the reputation that Perl has?
Well,
not that it's not good. It's what? What's its readability? Yeah, it's really difficult to read because they have lots of special symbols and lots of characters. And there's a joke that Perl programs are read-only. Like you write it once, and then you can never figure out what code you actually wrote ever again, so you can't modify it. So, and that's not a dig on Perl, because that was actually one of the first languages I learned. It actually had a lot of really cool features languages at the time didn't have. Things called regular expressions. It was one of the first powerful scripting languages that wasn't like crazy slow. So, but Python is on the other end of that spectrum. Python, they tried to make the code as readable as possible. And so what we have is certain conventions that make that code more readable. Now, in a language like C, so I'm going to write some code that, you know, this isn't valid Python code, but in C, you do something like this. You'd surround the code by curly braces. And any code surrounded by the curly braces in an if statement, if the if statement were true, that would execute. That should be pretty straightforward COP2030 stuff. However, in Python, they chose a different route. They chose indentation. And you'll notice, remember before I hit the enter key and all of a sudden my code broke? This is the reason why, is because in languages like C, they're called whitespace independent. Whitespace doesn't matter. So when I say whitespace, I mean the space bar, tab key, or the enter key. However, in Python, whitespace does matter. And so there's all these giant arguments that you could probably take you 2 seconds on the internet to find a giant argument about whether this is a good or bad idea. But this is the language choice they made. And the idea is that they made the choice for readability. So what you'll notice is that I do if age is greater than or equal to 18. Everyone knows what this symbol is, right? I don't really need to explain it. It's just greater than or equal to 18, which is the voting age. Or we can say that they can vote. Now, if I'm done with that if statement, actually let's put one more statement here. So don't forget to register to vote. Now, when I'm done with this if statement, what I do is I hit the backspace and I go back over one. So these two lines 4 and 5 are part of the if statement. But as soon as I hit the backspace key, line 6 is no longer part of that if statement. So you can run some experiments. So this person is 40. So they can vote. And then notice that this line always prints. And then if I change the age to say 17, nothing happens, okay? So make sure you're aware of that. So this is, by the way, this is a colon, not a semicolon. Just so that, you know, in case that is throwing anybody off. And to me, and I'll put some spacing here, but the idea is by making these sorts of language design choices, they wanted to make the language easier to read for junior level programmers, that you can read advanced code. I don't know if that's always the case, but that was the goal. You could make the argument whether they were successful in that or not. I don't know. Now, this does lead to a problem. What happens if I copy and paste some code off of the website? What happens a lot of times when you try to copy and paste code? What's the first thing to get messed up? Formatting. So what's probably going to happen to those spaces? It's probably going to be all messed up. So Python has a pretty bad reputation of taking code from the internet and copying and pasting it in your Python program. So you have to be very aware of that and very careful that if you're copying and pasting code, like say you go to like a Stack Overflow and there's like a couple of lines of code, like how to do a database connection or something, and there's like a few lines of code how to do that, and you copy and paste in your program. You just have to be very, very aware of this spacing, because white space does matter. It is actually important. And we have enough time. Let's just talk about else. Else is pretty straightforward. We just do else, a colon. Sorry, cannot vote. Yeah.
I mean, I guess that we deal with else statements as well.
Those are actually a little bit different. I guess I can show you that today. Okay. Well, let's do this. Let's save that for next class. It's not just the full words else if. It's actually this. So don't change your code. But if anybody's curious, what you do for an else if, you actually do elif. Okay. So that probably throws you off a little bit. We'll talk about that more in the next class. I think I did as much as I want to cover today. I don't need to cover the whole language in one class. Okay, so that's good enough for now. So let's talk about your assignment. What I'll probably do is next class maybe do a short lecture and then let you work on the assignment. Oops, let's bring that up here. Anytime, okay. So the assignment is, and you've seen this before if you've taken COP2030. The reason I like reusing some of these things is because, especially if you've taken the course before, you know what the assignment's about, you know the goal, you're just doing that goal in a new language, you know, so it kind of makes it a little bit easier. So I actually reuse these in like Java and some other classes. That way you can concentrate more on the learning the language than trying to solve the problem. In this program, what you're gonna have to do is convert Fahrenheit to Celsius. It is gonna have to be interactive. So it's gonna have to be like one of these liters to gallons type program where you ask them for the input, convert it, do all that stuff. That's what I say, Fahrenheit to Celsius. And then here I give you a little site with a, they have the formula. So we can't just use this as is. Let's go through that conversion process. So I have this. This is the formula. How would I translate this into Python code? Let's say we don't, by the way, just as a hint, don't try to use the full words Fahrenheit and Celsius because there's a good chance you're going to misspell it and then you're going to drive yourself crazy finding which time in your code you misspelled it. So lowercase c and lowercase f are good. Don't use capital C and F. Yeah.
Just a little side note, something that I noticed while I was working on the assignment is that the signs, like multiplication and subtraction, for some reason on Replit, both of those signs actually don't seem to work.
Yeah, always be careful about copying because sometimes what happens is that something that looks like a minus sign might be some weird Unicode character. So I would always suggest actually typing these from scratch. That may have been what happened is that, did you paste this formula and try to modify it? Yeah, it's weird. Sometimes like you'll have these characters that are technically Unicode characters and they look exactly like a minus, but there's some weird characters. I tend to, what's that?
There's supposed to be a minus in probably Unicode, but it's actually an ASCII. It's just not the ASCII value.
Yeah, it might be, sometimes it might be, you know, that double dash. It could be like that or a long dash or something weird like that. But, so I'm going to type this from scratch. So walk me through this. So obviously I can't have, it's not algebra. I can't have this on the right-hand side. So what do you think is the first thing I'll start with? So I say C equals, yeah, so it's going to be, it's not going to be 50F because they're providing an example value. So I'd do F.
I would recommend doing the parentheses first.
Yeah, so let's talk about that. So what's the difference? Actually, okay, so let's do this. I'm going to write it out as correct. So we're going to do F minus 32. And then I can't use the X. What do I use instead?
Asterisk.
Asterisk. And then don't do 5 divided by 9. I don't want to get into that right now. Python 3, the new version, actually lets you do that. Let's just do this for now. Let's just do 5556. Now, one big mistake I see in a lot of people doing this assignment, what's the difference between this with the parentheses and without? What operation happens first? It's going to multiply first. So don't forget, just like algebra, your order by wrapping this in parentheses.